In this video, we are going to look at inverse functions. Seeing as in previous videos we've talked about what functions are, we probably should start by talking what an inverse function is, and then how do we get them, how do we create them, and ultimately how do we graph them. So first, let's talk about inverse functions. When we talk about the word inverse, inverse means opposite. So we're basically dealing with opposite functions, and there's pretty much a simple way to do this. Let's say we have the function f of x equals x plus 2. If we were to graph this f of x we would treat as the letter y, because whenever we're graphing it's always a y equals sort of situation. So I'm going to rewrite this as y equals x plus 2. And if we graphed it, we'd get a straight line. It's a linear function. Well, how do I get the opposite of this? That's simple. All we have to do is take our y and our x and have them trade places. So I can move the x over here. I can move the y over here. And then all I have to do is solve for x. Solve for y. Because it's x all by itself, but I still want it to be y equals. So I gotta get this positive 2 to the other side. So I'm going to subtract 2 from both sides. And then my inverse function becomes x minus 2 equals y. If I were to graph these, you would see two distinct graphs. They would not look exactly the same. So if we're dealing with an inverse function, the main thing we're doing is just trading places with x and y. That's all we have to do. Let's try a different one. Alright, this time we want to find the inverse of the function of x, or the function f of x, equaling 4x minus 3. Well, like before I said, rewrite it so that f of x is y equals 4x minus 3. And then we got to take our y and our x, and they have to trade places. So it becomes x equals 4y minus 3. Now, my goal is to get y alone. So I have to do some algebra to make sure that y is all by itself. I'm going to add 3 to both sides. That's going to give me x plus 3 equals 4y. And then how do I get y by itself from here? Well, since it's 4 times y, I'm going to have to divide by y. So divide by 4. So divide by 4 on both sides. And our answer ends up becoming, if I trade places so that y starts it, y equals x plus 3. And I can't apparently draw a plus sign very good at the moment. Let me fix that. X plus 3 over 4. And that's our inverse function. We started off with f of x equaling 4x minus 3. And now we've changed it so that this is the function, and if we were to rewrite it in function notation, we could now say something such as g of x equals x plus 3 over 4. And in case you're wondering, why did I use g? Why didn't I use f? Well, f is already defined as this function, so since this is a new function, I have to use a new letter. Alright, let's try one more and actually try to graph this next one. Alright, this time we want to find the inverse of the function f of x equaling x plus 4, but we also want to graph the original function on our graph here and graph the inverse. So first let's start with graphing our original function, x plus 4. So that tells us whatever x is, we're going to add 4 to it, and that's going to be graphed as the y value. So let's say I have x equals 0, what is 0 plus 4? It's 4. So on my graph, x is 0 right there. Y is going to be at 4. So I can put a point at the coordinate 0, 4. That's a terrible coordinate. Let me fix that. 0, 4. There we go. Alright, now I just need to do one more and I can figure out the line because it's a linear equation. So let's say x is 3. Well, yeah, 3 would work. So if I add 4 to 3, my y coordinate would be 7. So I go over to 3 and I go up to 7, and there would be my next point. 3, 7. And now this line, I'll draw it as best as I can, is our function f of x. Now we've got to get the inverse. So just like I said before, we're going to rewrite this. So instead of being f of x, it's y equals x plus 4. And then we're going to trade places between these two. So we have x equals y plus 4. Now I have to get the y alone. So I'm going to subtract 4 from both sides. And I'm going to end up, well, let's show the subtraction, minus 4, minus 4. And I'm going to end up with my new function, y equals x minus 4. Okay, now I can graph this one. And it's going to work out just similar to this, except instead of adding 4 to my x values, I'm going to take away 4. So if I did 0 again, x equals 0, y is going to be 0 minus 4, which is negative 4. And that's going to be down here. And if I did 3 again, well, 3 minus 4 is negative 1. So I'm going to have over on 3, and then down 1. So it's going to be there. And I can get my inverse line. And that is the inverse function of our graph. And I could call this g of x, because I can use a new letter now, so g of x equals x minus 4. And there we go. That's all there is to it with our inverse functions. Just swap the x and y, and then solve for y. Not too tough. Now there is one other thing you'll see that we should be aware of, but it's the easiest part, so I figured we should save it for last. Alright, let's say we want to find the inverse of a relationship, such as a function, but all we're given are coordinates. Well, I said I saved this for last because it's the easiest part, I feel. So think of this. You've got a set of coordinates. Each coordinate has a x-coordinate and a y-coordinate. And what have we done in all of these inverses? Well, basically all we've done is swap x and y. So if all we're given is coordinates, that's exactly what we have to do. Instead of having 4, 3, the inverse would be 3, 4. Instead of having 2, 5, our inverse is 5, 2. And then lastly, instead of having 7, 6, the inverse is 6, 7. And there we go. We have given the inverses of our original coordinates just by swapping their values. Alright, hope you found this helpful. Good luck creating inverse functions.